everyone, we were going to talk about identifying the rejection region and hypothesis testing on the population mean.
Let's proceed to the example number 1. When population variance is known, the father of a senior high school student is listing down the expenses he will incur when he sends his daughter to the university. At the university where he wants his daughter to study, he hears that the average tuition fee is at least 20,000 per semester. He wants to do a test of hypothesis supposed from a simple random sample of 16 students. A sample mean of 19,750 was obtained. Further, the variable of interest, which is the tuition fee in the university, is said to be normally distributed with an assumed population variance equal to 160,000 and level of significance A equals 5% or 0.05. But of course, there are steps to follow to find the value. Step 1. We are done formulating the null and alternative hypothesis. Step 2. Identify the test statistic to use with the level of significance and distribution of test statistics. State the decision rule and specify the rejection region. What will be the appropriate test statistic to be used? With the known population variance, we can use z-test. What is z-test, by the way? A z-test is a statistical test to determine whether two population means are different or to compare one mean to a hypothesized value when the variance are known and the sample size is large. A z-test is a hypothesis test for data that follows a normal distribution. Back to what I was saying earlier, we will be using z-test for test statistic. We will be using the z-table as our critical or tabular value. If the population variance is unknown and the number of samples is less than 30, then we will be using t-test or the test statistic that follows the student's t-distribution with number minus 1 degrees of freedom, which means the tabular value in the student's t-table will be used as a critical or tabular value. In the given problem, the appropriate test statistic to be used is z-test, since the population variance is known. Let me have a quick explanation about the difference between z-test and t-test. Z-tests are used when we have a large sample size, like number greater than 30, whereas t-tests are the more sample with a smaller sample size, like number less than 30. Now, this is the formula to find the z-value. Z-value is equals to sample mean minus population mean over population standard deviation divided by the square root of the sample size.
This test procedure is referred to as one-tail z-test for the population mean when the population variance is known, and the rejection region is illustrated as follows. There's only one rejection region in this problem, and that would fall on the left side of our normal curve. Step 3. Compute the value of the test statistic. From the given problem, there are the observations or data gathered. Sample random is equal to 16. Our population mean is equal to 20,000. Our sample mean is equal to 19,750. Our population variance is equal to 160,000. And our population standard deviation is equal to the square root of our population variance. 160,000 is equals to 400. Hence, the computed test statistic is our computed C equals sample mean minus population mean over standard deviation divided by the square root of sample random equals to 19,750 minus 20,000 over 400 divided by the square root of 16 equals to negative 250 over 100 is equals to negative 2.5. Step 4. Make a decision rule. With the computed value of the test statistic equal to negative 2.5, the next step is to use the decision rule. Reject the null hypothesis. If our computed C is less than 2 to our negative C or negative critical value. Otherwise, we fail to reject our null hypothesis. Negative 2.5 is equal to our computed C is less than to our negative C or critical value equals to negative 1.645. The decision is reject the null hypothesis. Step 5. State the conclusion. Lastly, a consequence of the decision, conclusions are made which are in relation to the purpose of the test. Of hypothesis. With the rejection of the null hypothesis, we will accept the alternative hypothesis. Therefore, the father can say that the average tuition fee in the university where he wants his daughter to study is less than 20,000 pesos.
For example number 2, when population variance is unknown, the father of a senior high school student lists down the expenses he will incur when he sends his daughter to the university where he wants her to study. He hypothesizes that the average tuition fee is at least 20,000 per semester. He knows the variable of interest, which is the tuition fee, is measured at least in the interval scale or specifically in the ratio scale. He assumed that the variable of interest follows the normal distribution, but both population mean and variance are unknown. The father asks at random 25 students at the university about their tuition fee per semester. He is able to get an average of 20,050 pesos with a standard deviation of 500 pesos. Suppose the level of significance is set at 0.05. Step 1. Formulate the null and alternative hypothesis. The appropriate null and alternative hypotheses remain the same as in the previous lesson and are stated as null hypothesis, the average tuition fee in the targeted university is at least 20,000 pesos. In symbol, null hypothesis, the population mean is less than 20,000 pesos. Alternative hypothesis, the average tuition fee in the targeted university is less than 20,000 pesos. Alternative hypothesis, the population mean is greater than 20,000 pesos. For step 2, identify the test statistic to use with a given level of significance and the distribution of the test statistics. State the decision rule and specify the rejection region. This statistic, the population variant is unknown, and the number of samples is less than 30, then we will be using t-test or the test statistic follows the student's t-distribution with n-1 degrees of freedom, which means the tabular value in the student's t-value will be used as a critical or tabular value. In the given problem, the appropriate test statistic to be used is t-test since the population variance is unknown. The formula is the t-value is equals to sample mean minus population mean over population standard deviation divided by the square root of the sample size. Decision rule. The decision rule can be one of the following possibilities. Number 1. Reject the null hypothesis if computed C is less than your negative C or negative critical value, otherwise we fail to reject null hypothesis. Number 2. Reject the null hypothesis if computed C is greater than or negative critical value, otherwise we fail to reject null hypothesis. And lastly for number 3. Reject the null hypothesis if the absolute of computed C is greater than T with respect to your total test sample size or n-1, otherwise we fail to reject null hypothesis. For the given problem, the first is the appropriate decision rule because our null hypothesis use less than as equality symbol. The decision rule must not overlap with the null hypothesis. Since the level of significance equals 0.05 is its tabular value from the t-table is 2.064, the decision rule for the problem could be stated as reject null hypothesis if computed z is greater than minus t 0.05.24 equal negative 2.0.64, otherwise we fail to reject null hypothesis. This test procedure is referred to as one-tailed t-test per the population mean when the population variance is unknown. And the rejection region is illustrated as follows. As we can see, there's an rejection region below. This is for our guide on how we get the right answer.
So for the next step, compute the value of the test statistic from the given problem. These are the observations or data gathered. For sample random, it is 25, and degrees of freedom, we will be going to minus 1 from our sample size. So 25 minus 1 is 24. So our degrees of freedom will be 24. For population mean, it will be 20,000, and our sample mean will be 20,050. Population standard deviation is 500. Hence, the computed test statistic is 0.5. So from the given formula, we will be going to subtract the sample mean to population mean over the population standard deviation over the square root of sample random. In conclusion, computed test statistic will be answered after substituting the formula and the given. With the computed value of the test statistic equal to negative 0.5, the next step is to use the decision rule. Reject the null hypothesis if the computed test statistic is less than to negative alternative test statistic. Otherwise, we fail to reject our null hypothesis. The rule dictates that our decision is not to reject or fail to reject the null hypothesis. For the last step, we will be going to state the conclusion. As a consequence of the decision, conclusions are made which are in relation to the purpose of the test of hypothesis. Therefore, the father can say that the average tuition fee in the university where he wants his daughter to study is at least 20,000 pesos. That's all. I hope that you learned something today. Thank you.